everyone, welcome to the ArxLang channel. My name is Ivan, and today we will talk about a pull request I've been working on, and that's about the LLVM IR output implementation. So the previous work we talked about some videos ago, it was about the implementation for LLVM output, LLVM IR output, and it was basically based on the LLVM kaleidoscope chapter 9. All right. Remember that previously our compiler Arx was based on the LLVM kaleidoscope chapter 8. So basically the difference is very small, and in the previous implementation, what we did was we copied the entire code for the code generation, the AST to object, and we just added some few changes from the LLVM kaleidoscope chapter 9. All right, so it was not that good because we used a lot of boilerplate, and if you want to maintain that code, it is very hard to keep every change in one file into the another. So basically the motivation for this pull request was to avoid this boilerplate and remove that. All right, so let's jump to the pull request page. I hope you are seeing my screen here. So as you can see, basically I have changed just 4 files: the AST to LLVM, CPP, IR, CPP in the header, and the same for AST to object. All right. So I moved the LLVM IR visitor to the header. So if we go to the header file, we can see that now the visitor class is placed there. The same for the AST to object. So the class is here. And now another difference is that the AST to LLVM IR visitor now is inheriting from AST to object visitor. All right, so as you can see, we are just implementing the new attributes. We don't need to redefine all that attributes again. The functions, as we needed to add some code, we needed to redefine that, actually redeclare that. All right, same for initialize. This is a new one, if I recall correctly, create function type. All right, and these 2 other functions as well. All right, we don't need to redefine all that the previous functions or the functions or methods from AST to object visitor. So if we go to the AST to object header, we can see a bunch of attributes that we don't need to declare them again. These visited functions we needed to redeclare because we needed to implement a very small change. And these other functions, for example, main loop, we don't need to redefine that or re-implement that. And the same for get and create entry block lock. All right, so let's go back to our main file. So here we are just defining a new function, create function type. This is a new one. We removed a lot of boilerplate. Okay, here basically we don't need to re-implement everything. If you can see, we are just calling the visit method from the base class. So that's all the changes we needed to do. Basically, we needed to call the visit method from the base class. All right, and that is for all the visit methods inside AST to LLVM IR visitor, except, and this is really important, except for the function visit method. All right, and we'll see it really soon. So prototype, and it should be here, and it's not here. That's weird. Maybe another place. All right, this is the function and the file. Binary call visit. Oh, of course, because we didn't change the function, and that's why it's not in the diff stuff. That's the point. That's why it's not here in the diff. So for the for the function, the visit for the function AST, there's a lot of changes in the middle of the code. So at least for now, let's just keep it without this change, this calling the original function from the base class. So for now, at least, let's avoid that. Maybe we can revisit this function and check if we can do something similar. But for now, I think that's totally okay. All right. So basically, the changes is just about that. It's not a big change. We have now a lot of includes inside the header files that maybe it's not necessary here, or maybe not, probably it's not necessary. Let's just keep it for now. In a near future, that would be great to implement again the IWYU, include what you use, and it will help us to keep or include very consistent. All right, so for now, for this pull request, that's all. Let's now merge the pull request. All right, and done. Let's refresh the page. I'll delete my branch. Okay. So for the session today, I think that let's close this one. Done. This one. Just done. Okay. Close. Always good to close issues. All right. So we have a bunch of issues here. So let me see if there is something nice to work next. So something that's not here. We need to update this one. Yeah, I think this will be a very good one. Let's create a specific issue for this one. All right. Let's update this one. Create an option for generating an executable file. All right. So maybe tomorrow or this weekend, I will add more information here in this issue, and that will be a very good one. So when we completed this task, our compiler will have a lot of features like generating the LLVM IR, also the AST output. That's also really interesting. The file object output, that's already implemented. So just to give you a better idea what's happening in the compiler. So now the compiler is able to create the file object for any .arx file. All right. So that's nice. But if you want to just execute that file, it's not possible. We need to first create, using, for example, C++, we need to create a file with a main function, declare this external dependency. For example, if we are doing Fibonacci or another function, and we want to use it inside the C++ or a C++ program library, we need to use the only way we can have this function up and running is through another language, in this case C or C++, and that's not like what we want in general. We want to have an entire workflow just using Arx, but of course that's also really useful if you wanted to create something using Arx and reusing it using another programming language. All right, so that would be a very good next step, this option for generating an executable file. All right. Also, maybe we don't have this issue here. Let me open a new one. And this one is about infrastructure. And I love to work on infrastructure tasks. So the next step will be add containers sugar to the pipeline. All right, let me see what you can use for that. It should be in packaging, refactoring, support. Yeah, support works. Add containers, a new label here. All right, containers, and let me add some information here. So in this case, the link to the containers sugar. All right, this is a new project. Basically, it's organizing and help us to work with a better workflow with Docker Compose, or also Podman Compose as well. It should work. It doesn't have tests yet for Podman, but basically it shouldn't change too much. And let me open here the project as well. But basically, we have here a makefile with a lot of targets. Well, not that much, but we have some targets here for containers. But the point is, if we want to have something more robust, we need to add more targets to the makefile, and the makefile will look very ugly. So the idea here is to move all these targets about containers in general, and we should start to use the container sugar. So we will have a file with some configuration here about the service and so on, and to use the commands it will be really easy. So why also it's important if we just have one container? It doesn't make too much sense, right? The point is we also should start to implement more Docker configuration here, not for the compiler, but for some tools that will help us to keep our code with a better quality. All right, so that will be the second next step for us as well. All right, so also feel free to jump into any issue here, add your comments, open new issues here, and we can discuss any of them in other videos, in another streamings, and that will be great to receive more contributions here. All right, so I think that's all for today. Thank you for watching. Subscribe to our channel. Ensure that you will receive all the notifications so you can keep learning about Arx project. Also, maybe something about C++, LLVM, and the other tools we are using here for our entire workflow. So, thank you so much, and I'll see you soon.